In this section, we will be looking at both the normal physiology of the lungs and the pathophysiology of the diseased lung. The respiratory membrane separates the air in the alveoli from the blood surrounding the capillaries. Several variables affect the efficiency of alveolar gas exchange. 1 is the solubility of gases, 2 is membrane thickness, 3 is membrane area, and 4 is ventilation-perfusion coupling. These are explained in more detail in the in-depth section. Diffusion of gases is a passive process that results in movement down a concentration gradient, similar to air pressure to allow airflow in and out of the lungs. Blood low in oxygen flows into lung capillaries due to oxygen being continually used by cells of the body. Alveolar air is rich in oxygen, diffusion causing the movement of oxygen from an area of high concentration in alveolar air to an area of low concentration in capillary blood. Most oxygen entering blood combines with hemoglobin in the red blood cells to form oxyhemoglobin, so that it can be carried to the tissues and utilized by cells. Blood flowing through the lung capillaries is high in carbon dioxide. Most carbon dioxide combines with water in the blood to form carbonic acid, which then dissociates to form hydrogen and bicarbonate ions. These ions affecting the pH of the blood. Some carbon dioxide combines with hemoglobin in red blood cells to form carboaminohemoglobin. Carbon dioxide dissociates from bicarbonate and carboaminohemoglobin molecules and diffuses from an area of high concentration in the pulmonary capillaries to an area of low concentration in alveolar air. Carbon dioxide then leaves the body in expired air. The partial pressure of a gas represents its level dissolved in plasma. Normal systemic arterial blood has a partial oxygen pressure of 95 mm of mercury and a partial carbon dioxide pressure of 40 mm of mercury. With a pH of 7.4, the rate and depth of breathing is then adjusted to maintain these values. Of these three chemical stimuli, the most potent stimulus for the adjustment of breathing is pH, followed by carbon dioxide and the least significant oxygen. This adjustment possible because the brainstem respiratory centers receive input from central and peripheral chemoreceptors that monitor the composition of the blood and the cerebral spinal fluid. Diseases that affect lung function are caused by one of two patterns of dysfunction, restrictive or obstructive. Restrictive lung diseases are characterized by a reduction in lung size or an increase in lung stiffness, resulting in a decrease in the maximum volume of air that is able to be moved in and out of the lungs. An example is pulmonary fibrosis. Obstructive diseases are those characterized by a reduction in airflow and airflow limitation, including asthma and chronic obstructive pulmonary disease, or COPD. In this resource, we will briefly look at obstructive diseases that require greater force to provide adequate ventilation, with these factors that reduce airflow also compromising particle clearance. COPD refers to any long-term obstruction of airflow and the substantial reduction in pulmonary ventilation as a result. The major conditions that make up COPD are chronic bronchitis and emphysema. They are almost always caused by cigarette smoking, but occasionally result from air pollution or occupational exposure to airborne irritants. COPD progressively causes permanent damage that is predominantly irreversible. Normally, the anatomical components of the respiratory tract and lungs cleanse, warm, and humidify inspired air, due to general contamination of inspired air with irritants. Mucus is produced by goblet cells and moves up the respiratory tract from the lower portions of the bronchial tree on millions of hair-like cilia that cover the epithelial cells of the respiratory mucosa. The layer of protective mucus that covers the large portion of the respiratory mucosa lining the respiratory tree serves as the most important air purification mechanism. The microscopic cilia beat or move in one direction, resulting in the movement of the mucus towards the trachea. Impaired ventilation and clearance predisposes to infection. Bronchitis is inflammation of the bronchi mucosa characterized by hypertrophy and hyperplasia of the glands and goblet cells lining the bronchial airways. The cilia is immobilized and reduced in number, while goblet cells enlarge and produce excess mucus due to the inflammation. With extra mucus and less cilia to dislodge it, thick stagnant mucus in the respiratory tract restricts airflow and provides a growth medium for bacteria, causing chronic infections and further bronchial inflammation. In emphysema, the alveolar walls break down and disintegrate, producing permanent abnormal enlargement of air spaces that remain filled with air during expiration, with larger but fewer alveoli resulting in significantly less respiratory membrane available for gas exchange, reducing diffusion across the damaged alveolar capillary membrane. The lungs become fibrotic and less elastic. In advanced cases, parts of the lung may look like flabby, empty airbags instead of showing the spongy texture seen normally, with air passages opening adequately during inspiration, but tending to collapse and obstruct the outflow of air. Air therefore becomes trapped in the lungs, and over a period of time a person becomes barrel-chested. Overly stretched thoracic muscles contract weakly, which further contributes to the difficulty of expiration. People with emphysema become exhausted because they expend 3 to 4 times the normal amount of energy just to breathe. Even slight physical exertion can cause severe shortness of breath. Overall, COPD tends to reduce pulmonary compliance and the total capacity for air to enter the lungs during respiration. Asthma is characterized by inflammatory changes in the airway wall, leading to irritability and increased responsiveness to various stimuli. Exposure to allergens or irritants causes mast cells to release granules and trigger the release of many inflammatory mediators. Even though it can be chronic, asthma tends to be more intermittent and acute than COPD, with the condition in most cases reversible with bronchodilators. Major events in an acute asthma attack are mucus hypersecretion, bronchoalveolar constriction, and inflammatory swelling that varies in severity. The airway mucosa also remodels in response to inflammation, going on to either resolve itself or result in pulmonary fibrosis. To see more information, see the in-depth section.